Hi, I'm Andrew Halleck, and this is my lab 2. So I have three functions in my script. There's a square wave, a sine wave, and a triangle wave function, each taking an amplitude and a frequency. In the square wave, it begins by finding the period being 1 over the frequency, and then it finds the ratio of the inputted amplitude to the maximum amplitude allowed, which is just the maximum voltage allowed. And then it goes through this infinite loop, and it first outputs the DAC value with the ratio times the maximum voltage in bits, and then there's a sleep period, which is the period divided by 2, and then it does the same thing, but instead it sets the voltage to 0 and does that same length sleep period. After that, it receives it waits for a keyboard interrupt, at which it begins the entire program again to select between the three types of waves. The sine wave function also takes in an amplitude and a frequency, and instead of using a period, we use a time t and a step that increments t. And then it still calculates the ratio of the amplitude to the maximum voltage. And now there are new variables as well. There's A, which is the ratio times the maximum voltage in bits divided by 2, right here. And then there's an omega, which is 2 pi times the frequency. So what happens is it goes through the loop, and the raw value is equal to A times sine times omega times t plus A. So the whole point of that is it offsets the voltage a little bit so that it can never go below 0, and instead does a sine wave that is higher on the y-axis. So then t will step up, and then there will be a sleep that is equal to step. So the triangle wave also takes an amplitude and a frequency, and it still uses a time t and a step and a ratio, but this time there's a delta, which is equal to the frequency over 50. The whole point of that is so that each peak of the wave will land on the correct period. And then there's also a voltage that is initially set to 0, and A, which is the ratio times the maximum voltage in bits again. So what happens is it adds the voltage, it adds A times the delta to the voltage, and then it outputs that to the to the DAC. And then it checks if we've reached the maximum voltage allowed or the minimum voltage allowed, and then delta equals negative delta, and it repeats the process over and over again. On the breadboard, we have the DAC chip wired, and then we have channel 1 of the analog discovery set to the Vout of the DAC chip. Here's the program actually running. So the program prompts the user for an input. If the input is 1, it's a square wave. If it's 2, it's a sine wave. If it's 3, it's a triangle wave. So we'll start with a square wave. So we'll press that, and then it will prompt for the amplitude. For now, we'll do an amplitude of 2 volts, and then it will prompt for a frequency. We'll do 5 hertz for the frequency. So here's the square wave running at 2 volts and 5 hertz. As you can see, the maximum voltage is 2, and it is running at 5 times a second. Now if we press Control C, it will stop the current wave, as you can see. It stops the wave, and it will restart the program and prompt the user again. So this time we'll do a square wave with 1 volt amplitude and let's say 3 hertz for the frequency. So now you can see the square wave is a little bit slower, and the voltage is 1 for the amplitude. So then we'll Control C again, and now we will do the same sort of thing for the sine wave. So we press 2 for sine wave, and we'll do an amplitude of 1.5 volts, and then we'll do a frequency of, let's just say, 2 hertz. So here you can see it, 1.5 volts, and it is doing a cycle every 2 seconds, or every half second. So you press Control C to stop the program. As you can see, it stopped. We will do the sine wave again, and this time we will do an amplitude of, let's do 1 volt, and let's just do 8 hertz, sure. So here you can see there's a little bit of noise, but that is a sine wave doing 1 volt at 8 hertz. So I'll press Control C again, and we'll do the triangle wave now. So for the triangle wave, we press 3, we'll do 1 volt amplitude, and we'll do a 1 hertz frequency. And as you can see, a triangle wave has been created. We can restart the program. We will do triangle one more time. And this time we will do a 2 volt amplitude and a 6 hertz frequency. And as you can see, it outputs correctly.